Good morning, everybody. We'll go straight to the presentation of the Interactive Atlas, starting with the presentation by Valerie Masson, who will introduce the Interactive Atlas in the broad context of the Working Group 1 report. Thank you very much, Valerie, for being here with us. The floor is yours. Yeah.
Thank you very much, dear ministers, dear presidents and vice presidents of scientific institutions, dear colleagues, friends, ladies and gentlemen. It's an honor and a pleasure to be part of this event, and I express my deepest gratitude to the Spanish government and institutions who have supported the preparation of the report and specifically this novel interactive atlas, and all the scientists who have devoted so much time and efforts and skills to turn a wish into a reality. Our 2021 climate report is the outcome of a co-design process where we carefully considered the demands expressed by IPCC member governments as well as recent science advances. And 5 years ago, high expectations were expressed by governments for a strong emphasis on the link between the changing global state of our climate and the multiple resulting characteristics in every region. Regional information is indeed critical to understand what climate change means where we live in every region and what to prepare for, therefore contributing to risk assessments and to inform decision-making. Since our previous report in 2013, there's been an impressive increase in available scientific information from regional-scale climate studies, with progress in observations, in the use of global and regional models, and in understanding what shapes regional climate variability and change. Methodologies have emerged to integrate multiple regional climate information sources and to develop context-specific, actionable climate information. The idea to develop an interactive product was an outcome of a 2018 IPCC expert meeting in Trieste, Italy, on assessing climate information for regions. It is now a reality. I will introduce how this interactive atlas sits within the 2021 climate report on the physical science basis of climate change and its key findings. As a starting point, I want to flag that from advances, from enhanced observations, process understanding, modeling studies of past climates, we now have a clearer picture of how the Earth's climate functions and how human activities affect it. We know better than ever how and why the climate has changed in the past, is changing, and how it can change in the future. So where are we now? We all live with widespread, rapid, and intensifying characteristics of a changing climate. And the scale and rates of the changes now are unprecedented in thousands of years or more. Let's look at one of the key indicators of the state of the climate: global surface temperature change. Each of the last 4 decades has been successively the warmest on record. The observed warming is now reaching 1.1 degrees Celsius in the last decade compared to the late 19th century. What has caused the observed warming? We look at natural variability. Natural variability results from internal variations and from the response of the climate to solar and volcanic variability. As you see, it has little effect on centennial global warming, but it modulates human-caused changes, especially at regional scales and in the near term. Our best estimate is that all the observed global warming is caused by emissions from human activities, with warming caused by emissions of greenhouse gases, partly masked by cooling from pollution particles, which we call aerosols. Warming is driven by our emissions of carbon dioxide, mostly due to burning fossil fuels and deforestation, with also a growing effect of methane, also resulting from the use of fossil fuels and some agricultural activities. Human influence is the main driver of many changes in the atmosphere, in the cryosphere, everything that is frozen or with ice, over land and in the ocean. It is the main driver of sea level rise, which is occurring at an accelerating pace. Human-induced climate change is already affecting every region on Earth in multiple ways, and it's already strengthening the frequency and intensity of multiple extreme events. Hot extremes, including heat waves over land and in the ocean, have become more frequent and more intense. Many recent hot extremes would have been extremely unlikely to occur without human influence on the climate system. Heavy rainfall events have become more frequent and more intense. Human-driven climate change worsens droughts around the Mediterranean Sea and in other regions. Fire weather, which is the combination of dry, hot, and windy conditions that is conducive to wildfire, is becoming more frequent, affecting larger areas and for longer seasons in many parts of the world. Multiple changes are taking place in the ocean, which is warming with more marine heat waves, acidifying and losing oxygen, affecting marine life and those who depend on it. We're not prepared to face these ongoing changes yet, and they will increase with further warming. So what are our possible climate futures? Unless there are immediate reductions in greenhouse gas emissions, warming will continue to increase. We will reach a level of warming of 1.5 degrees Celsius in the coming decades. But we can still limit warming close to that level. And let's look at that in more detail. Our assessment confirms the close relationship between cumulative emissions of carbon dioxide, so the sum of past, present, and future carbon dioxide emissions, and the level of global warming. Every ton of CO2 added in the atmosphere will add to more warming. In this report, we look at a range of scenarios. Scenarios where emissions start decreasing fast at a strong rate in blue. Emissions where they stagnate for a few decades at today's level in yellow. Scenarios where they continue to increase in red. In all cases, even if emissions decline now, the cumulative emissions will continue to increase until they reach zero at the global scale. So when we look at the assessed response of global surface temperature to this range of scenarios, you can see that under all emission scenarios, global surface temperature will continue to increase until the mid of this century. We will soon reach a level of warming averaged over 20 years of around 1.5 degrees Celsius. If there is no more ambition than today's pledges from governments, implying a stagnation of global emissions at today's level by the 2030s, if emissions continue to stagnate close to today's level for a few decades in yellow, then we would reach and surpass a level of global warming of 2 degrees by the middle of this century, and in that case, more than 3 degrees in the coming one. But if action is taken to rapidly and strongly reduce emissions of CO2 and other greenhouse gases, global warming can stay well below 2 degrees and close to 1.5 degrees Celsius, which are the goals of the Paris Agreement. The changes that we already have to face in every region will increase with further warming. A warmer climate will intensify the water cycle and its variability, including very wet and very dry weather and climate events and seasons, with implications for flooding and drought risks and for water management. Many changes in the climate system become larger in direct relation to the level of global warming. This includes annual mean temperature trends in every region and contrasted annual precipitation trends, including a decline around the Mediterranean Sea in every region. For every fraction of additional warming, we need to prepare for further increases in the frequency and intensity of hot extremes, heavy precipitation, droughts in some regions, an increased proportion of intense tropical cyclones, and reductions in snow cover, permafrost, in mountains, in the Arctic and Arctic sea ice. We have set up in motion the slow components of the climate system. Glaciers will need decades to adjust to today's warming. Changes in the deep ocean, including warming, the response of the polar ice sheets, are irreversible for centuries to millennia, and they will drive further sea level rise. It is certain that sea level will continue to rise, but the rate, the magnitude of rise depend on future greenhouse gas emissions. Our report, as you can see, provides a wealth of knowledge in terms of climate information for risk assessment, for regional adaptation for all regions. And we look at that through the lens of what we call climatic impact drivers, physical changes in the climate system, trends, extremes, but also values above known tolerant thresholds, which we already know lead to impact. So the report explores how these climatic impact drivers will be experienced in every region. And we show that these changes will be more widespread, more pronounced, with every additional fraction of global warming. The good news is that the slow, the long-lasting changes, they can be limited, and the other ones can be stopped by limiting global warming. So from just a physical science perspective, what does it take to limit future warming? It requires limiting cumulative CO2 emissions, decline in emissions reaching at least net zero as soon as possible, along with strong reductions in greenhouse gases, and we stress the importance of reducing emissions of methane because it brings multiple benefits, not just for limiting warming, but also to improving air quality. And reduced global greenhouse gas emissions would lead within years to visible impacts in the levels of these gases in the atmosphere, in air quality relative to high emission scenarios. The effects for trends in global surface temperature would be seen within around 20 years. So, as you can see, the climate we experience in the future in every region depends on your decisions now. And the report provides a wealth of information, including around a third of the report focused on regional climate information. Please read this report, our regional fact sheets. There are 2-page summaries for various regions. And please use this knowledge to understand what is at stake, to inform your decisions and to take action. This report does not replace the need to go further in knowledge developments, especially to develop knowledge that is specific for specific needs, specific contexts, as actionable climate information is the outcome of the co-design, the co-production between scientists, practitioners, and users. The Interactive Atlas thus brings a new dimension to our 2021 climate report, enhancing the accessibility of the best available climate information at regional scales, allowing you to explore what climate change means where you live, for what you care for, to explore the multiple characteristics of a changing climate in every region. It's also a novel tool for education and training, and to enhance climate literacy. It's critical to better understand the links between greenhouse gas emissions, the global climate system response, and the implications in every region, so as to understand what to prepare for. I will end this here, but again would like to express my deepest gratitude to the scientists present here and in the room, and those around the world who have been involved in the development of this new tool. It is the impressive outcome of tremendous efforts using best practices in data science to make the wealth of information from this report easily accessible. Thank you.